So 4.2 is about solving quadratics by graphing. And I want you to think about it in terms of how we solve systems by graphing. There was important points that we needed to focus on to find solutions to systems. Quadratics have the same type of characteristic. There's certain points that I'm going to want you to focus in on to determine the solutions. Later on, tomorrow, actually Monday, we're gonna start solving quadratics by factoring, which you've done before. But I want to start off with graphing. Now, what I'm about to put on the screen is in your book. You can screenshot it from your book. I've put the page there. Or you can take a picture of the screen. It's your choice. And then after you get it situated, I will talk through it so you know what's going on. Here it is. Okay, so we've spent a lot of time with linear functions and even at the beginning of quadratics talking about y-intercepts and why we think those are so important. The truth is x-intercepts are more important. And with a quadratic, we can have one of three possible situations as far as solutions go. You can have one real solution, okay, like this, and that point, that vertex where it touches the x-axis is the x-intercept. That's where I'm going to find one of my solutions. Another scenario is where I have two real solutions, where the parabola crosses the x-axis twice. There are two x-intercepts. That's where I will find my solutions. Or we could have a situation where the parabola doesn't ever cross the x-axis, which means there are no real solutions. In your homework tonight, you're going to identify, in some respects, you're going to identify the solutions from the graphs. You're going to be provided some graphs, and you're just going to have to say what the solutions are. And I'm going to talk to you about how to find those. Okay. The solutions, and this is what I just said, the solutions can be found at the x-intercepts of the quadratic. So again, we're focusing on the x-intercepts for solutions. Now there's a couple other terms that mean the same thing as solutions, and I want you to get used to those. Okay, just know that all three of the terms that I'm going to show you besides solution, the two others, they can be used interchangeably. They all mean the same thing. So if you hear or you read them referred to as zeros, we're talking about solutions. If they are referred to as roots, we're talking about solutions. All three of those things mean the same thing. The context of the particular problem will determine which one they use. Okay? Zeros, roots, solutions all mean the same thing. Okay? Know that you can use them interchangeably, and they will be used interchangeably. And I just want you to be sure that you know they all mean the exact same thing. Let's look at what we need to actually do. So this is one type of equation, one type of problem you're going to see in your homework tonight. You're going to be given a quadratic. We know it's a quadratic because the highest power on the variable is 2. And we're going to use your graphing calculator to graph this parabola. Okay. Now, if you remember anything about quadratic equations, we have to do something first before we can do anything. Anybody know what that is? Anybody remember? Ivan? Chris?
It's something about, it's like, has to add up.
No, you're trying to factor.
Yeah, that's what I was thinking.
Yeah. Nope. Something we have to do first. Yeah? Nope. Aiden? What? Standard form, which means? No, not quite. That doesn't matter for this. Nick? No, not necessarily. Yeah? No. Okay, I'm going to tell you. Make one side equal to 0 first. Make one side equal to 0. Okay. Which is sort of standard form, right? We're getting the ax squared, the bx, and the c all together on one side. So that's where I thought you were kind of going with that. So what should I move here? What should I do? Add 12 to both sides. So that will give me x squared minus 8x plus 12 equals 0. So now it's in standard form. Once it's in standard form like that with one side equal to 0, we are ready to graph. Okay, and we're ready to input it into our calculator. The only difference is we treat that 0 in terms of graphing as a y. Okay, so now I'm gonna walk you through what you need to do in order to enter this into your calculator. Okay, so the first thing you need to do on your graphing calculator, hit the top left button, the y equals button. Top left, very top left corner. Y equals button, the very top left corner. Hit the y equals button. You will get a screen that says y1 equals, y2 equals, y3 equals. Okay, you'll get a whole bunch of different possibilities for graphs. First thing I want you to do is clear out any equations that are already in there. So if you have equations, clear them out, delete them out. Okay, you can press clear, you can press delete. I think they will both work. Okay, so that's the first thing you want to do. The second thing I want you to do is look up at the top where you see the words plot 1, plot 2, plot 3. If any of those are darkened in and highlighted, you need to unhighlight them because your graph won't work. So if it just says plot 1, plot 2, plot 3, and none of them are like in black with like a highlight, then you're fine. Okay? If they are, just go up to the word and click enter and it will unhighlight it. Okay? Those are the first things you want to do. Make sure that your calculator is in good shape to do that. Okay, the next thing I want you to do is I want you to actually enter the equation in. Now, you can use the x, the letter x, but it's not my preference that you use that. Next to the green alpha key, there is a button that is labeled x, comma, t, comma, theta, comma, n. That is the variable button. It is preferred that you use that button because it is the variable. So when you enter this equation in, x squared minus 8x plus 12, just use that button next to the alpha button to put x in.
We do that in y1?
Yep, do it in y1. Additionally, be careful. Do not enter a negative when you should be putting a subtraction sign. So that minus 8x, in this case, it does make a difference. At the very bottom of the calculator, you'll see a negative in parentheses. That's not what we're using. We're using the minus. So you have two options for the squared. There's an x squared button on your calculator. If you press that, it'll give you the little squared. You can do the caret, which is the button that looks like this, okay? And that means raises to the power. Honestly, if it were me, I'd use the x squared button, okay? Now, anybody having trouble getting that entered in? Once you have the equation entered into the calculator, all you need to do is hit the far right button that says graph. Okay, the far right button that says graph. Now, anybody having an issue getting a graph?
That's crazy. That's cool.
I know, it's cool.
That's actually dope.
Now let's talk about a couple things. Okay, for this particular graph, it's kind of obvious where the solutions are. Now, what happens is, okay, on all of your windows, because you haven't played with this before, it's already set up to go to the standard window, which is a 10 by 10 window. Negative 10 to 10 on the X, negative 10 to 10 on the Y. I cut mine off a little bit because there's nothing below here, but notice my top and left and right are all 10s. Okay. You're going to want to zoom in and zoom out, and I want to show you how to do that. But before we get there, I want to talk about the solutions for this particular one, and then we'll play with how to zoom. Okay. What is the x-intercept for? What are the x-intercepts for this parabola?
2 and 6.
So 2 and 6. It's very clear that they cross at an integer. That's going to be important. They're not always going to cross at an integer. So my solutions are just x equals 2 and 6. Or you can write x equals 2 comma 6. Do not express it as a point. Even though it's the x-intercept and those are points, The solution is actually just the x value. Now let's start, I want you to zoom in on your graphs a little bit, and I want to show you how to do that. Okay? So there's a couple things that I'm going to walk you through. First of all, the zoom button, which is in the top middle, I want you to press that. And you'll get a whole menu there, and I think the first one down is zoom in. Is that right?
Yeah.
So now, here, hold on, don't do anything yet, okay? When you hit enter, it will not zoom in yet. When you hit enter, you're telling the calculator you're almost ready to zoom in, and you're going to tell it where. So go ahead and hit enter, and nothing will change except it'll go to the graph, and there'll be a cursor there. Okay, I want you to, with your arrows, move the cursor around and get it to the first x-intercept on the left. Get it in that area. Now notice as you're doing that...
It doesn't go to exactly 2.
It doesn't, correct. As you're doing that, at the bottom of the screen, it's giving you the coordinates of your cursor on the grid. So as you're moving around, it gives you the x, it gives you the y. So as you get closer to that area, now hit enter, and it will zoom in on that point. Okay, this is going to be important for the next example that we're going to do, because you need. We're going to get there too. Okay, now so you see how it zoomed in on that area where your cursor is. That's the key. You have to tell it where to zoom in based on the cursor. Now. So you can zoom out and go back and do it the same way. Hit the zoom button, zoom out, and hit enter again. But most of the time we're going to want to get back to that standard 10 by 10 window. And so the way we do that, first of all, is anybody having trouble zooming in? Okay, let's go to the next thing then. Let's get it back to the standard window. Hit the zoom button again, and you'll see the sixth one down says Z standard. Hit enter on the sixth one down, and it will take you back to the 10 by 10 window. Okay, so you can basically undo that zooming in by going to the standard window. Okay, and that's where I want you to be at this point. Now, any questions before we move on to the next example?
That's all we do for those problems.
So one of the types of problems that you're going to see is going to be like this. It's going to have an equation, it's going to ask you to find the solutions, and you can just pick them off from the graph. Now, there's another type of problem that you're going to see, and it's going to look like this, where the directions are a little bit different. Okay, so go ahead and write that down, and then we'll talk about what we need to do here. So after you get this problem written down, go ahead and get the old equation out of there, enter the new one into your calculator, and graph it. Now, you could have put another one on there too, and it'll even, for the newer ones, the CEs, it'll be in color, and each graph will be a different color. But at this point, let's just get rid of the old one. So enter that in, and then graph it, and then we'll talk about what we're going to do for solutions. Anybody having trouble getting this one graphed? Now, here's what it looks like. Again, my window's a little different than yours because I wanted to make sure it all fit on the screen. Here's the thing that you notice, okay? The x-intercepts don't cross at integers, okay? And that's why these directions, if exact roots cannot be found, state the consecutive integers between which the roots are located. On your calculator, in order to find some of those, you're probably going to want to zoom in on those points and get as close as you can so you can determine what integers they are between. Now,
what did I just do?
It's fairly easy, okay, to tell where those points are and that they missed. But if you aren't completely sure, so for example, on this one, we have a solution here between 0 and 1. And that's what we want you to say. I don't want you to zoom in and zoom in and zoom in and try to guess what that value is for x. The directions in the book are going to be just like this. Just say that one of the solutions is between 0 and 1. Consecutive integers. Okay? What are the integers for the second point going to be? What consecutive integers is this point in between?
5 and 6.
5 and 6. Okay?
So we don't even really have to like.
You're not going to actually find the solution today from the graph, okay? So this one is going to be between 5 and 6. So that's all you're going to do for your homework tonight, okay? So you've got those ones there, those ones there. For your zooming in and zooming out, your zoom standard is going to be your saving grace. When you get zoomed in so far and then you can't figure out how to zoom back out the right way, because you can go in and zoom out and zoom out and zoom out, it'll never quite look like it did at the beginning. That zoom standard will always take you back to that 10 by 10 window. And if for some reason you're working on another problem and that it's not fitting in the 10 by 10 window, you can manually adjust the window with the window button. So it'll say X minimum, X maximum, so that's telling you what width, how far to the left it'll go, how far to the right it will go. You can adjust with the Y minimum and the Y maximum to see how high or how low it goes. Okay, but that's what you're doing tonight.